This is General Physics UT Quest problem, more forces in two dimensions. This is a suspension problem where we have an object suspended from a ceiling and a wall. There's an easier way to solve this problem. Normally, the way we did this in class, we looked at an equilibrium equation in the x or horizontal direction, and then looked at an equilibrium equation in the vertical direction, and we usually had simultaneous equations to solve in order to figure this out. And that will work on this problem, but what I'm going to do here is going to be significantly easier. Instead of approaching it like that, we're going to approach it as an equilibrant problem. And the reason we're going to do that is what I have drawn in purple here is what we know. I know the cable in the cable on the right-hand side of the drawing. I know its tension. I know its angle. I know the weight. The things in red are what we need to solve for. We want the tension in the left-hand cable, and be careful here. We want the angle with the wall, so that's where I've drawn theta here. Okay, so what we're going to do is a normal approach. We have this cable on the right, and we know its magnitude, and we know its direction, so we can easily break that into components, and that's exactly what we're going to do. We have everything we need to take this cable on the right hand and break its tension into a horizontal and vertical component. Now I'm going to do the same thing with the cable on the left. I'm going to break it into x and y components. I'll just call that tension in the left-hand cable in the horizontal direction. And then we use our knowledge that these two forces are in equilibrium with the tension in the x direction of the right-hand cable. So that value that I got right here, I can use for this value right here. All right, so I've already got the x component of the tension in the left-hand cable in the horizontal direction. Okay, now let's try to find the vertical component, and that's going to be a little bit more complicated. We're going to call this tension of the left-hand cable in the vertical direction. I've got three vertical forces, but I'm in equilibrium, a little bit more complicated than what's happening in the x direction. So let's go ahead and write it out, see what we got. I have the tension in the left-hand cable pointed up. I have the tension in the right-hand cable pointed up. And I have the weight. These are the quantities with my check mark. So I'm able to calculate then the tension in the left cable in the vertical direction. Now it's just math. Okay, so I have the vertical and horizontal components of the tension in the left-hand cable. So by Pythagorean, I can find the magnitude of the tension in the left cable. And now I can use trigonometry to solve for the angle theta. Now I'm able to use my force diagram for geometry because our force diagrams in our geometry share direction only, so be careful with that. So this is legitimate. I can solve my force triangle for this angle theta because I know that the direction of that tension has to be along the geometry of the cable. And so that solves this problem. Good luck with it.